Welcome back. All right. So this lecture will be short. I would like to talk about runtime assurance. So let me start with the definition. So RTA stands for runtime assurance, also known in the computer science literature as shielding, is a mechanism that ensures an agent to operate safely. So basically it is a mechanism on the background, sometimes called as the secondary controller's safety mechanism. Basically, it acts like a safety layer in the background and it modifies agents' actions if they are not safe. So before I dive into properties, for example, consider an autonomous vehicle that navigate through dynamic environments with pedestrians and other vehicles. So in this case, the objective of the reinforcement learning policy is to optimize for efficiency and speed. And in this case, the runtime assurance mechanism acts as a secondary safety controller and, for example, monitors the vehicle's distance to the pedestrians and other vehicles. And it intervenes with the vehicle only when, for example, vehicle is about to hit to a pedestrian or any other vehicle. You can also maybe familiar with, from factories, robotic manipulation. For example, let's say a robotic arm is, learning to grasp the objects, and when there is a human, basically it cannot hit the human or any other robot. So basically, it works in a collision-free way. So if an action is about to, if it chooses an action which is toward a human or another vehicle, this runtime assurance mechanism prevents it. All right, I think you got the picture. So some of the properties are real-time intervention. So because it monitors actions before execution and intervene if necessary. Minimal intervention is important. So, right, you don't want it to override the efficiency of the algorithm. So it only overrides actions that violate safety constraints. Again, it can be, hitting a vehicle, pedestrian, you name it. And sometimes, since it acts on the background, it may be transparent to the agent, so agent may not be aware of the runtime assurance mechanism. And another property I will say, it is policy independent. Basically, if whether you are using Q-learning, SARSA, or another method, you name it, basically runtime assurance operates independent of agent's learning algorithm. All right, so we are, if you are driving a new car, another runtime assurance mechanism, like if, holding your lane, if for some reason you are about to switch a lane without a signal, vehicle prevents you doing so. All right, we are going to consider the grid world example because we did a lot of toy examples. So this is the next video we're gonna consider grid world example. And on that example, I am using a runtime assurance mechanism, and you are going to see the code. Actually, I will share the code since it is a little bit, if my memory is correct, over 300 lines. So in this case, in the grid world example, an agent navigates in a 10 by 10 grid world with obstacles. These are the obstacles, and the goal is to reach this green square, and the aim is to find the shortest path without colliding with obstacles, right? This is, of course, these arrows shows after I train. This will be the end result of the next video. This is after several iterations, and if you are, for example, starting from here, policy tells go like this, follow the arrows because this is the shortest path. Obviously, if you are starting here, go like this. So here, you can avoid collisions in two ways, or going off the grid, right? So for example, let's say you are here and during training, agent takes an action toward this direction, you can give a negative penalty. You can, going off the grid, -10. If you are here and taking action toward an obstacle, -10. You can introduce negative rewards in the training. However, I am not going to do it that way because, bear with me, I will explain the reason. Instead, I am using runtime assurance mechanism that filters the agent's possible actions to only those that are safe. So basically here, before agent takes an action, runtime assurance filters the action so agent can go only like this and like that. You cannot go, this is not a safe action, and going off the grid, this is not a safe action. So to make the long story short, the agent selects actions from the filtered safe list. So the reason why I am using runtime assurance in real-world applications as opposed to, during the training, giving negative penalties for going off the grid or toward an obstacle is because runtime assurance reduces the action space. And this is especially can be important for complex scenarios because since it reduces the action space, potentially this can speed up the learning process so that you can learn faster. You can finalize the training faster. All right, as is being said, if you have any comments, write it down. I will try to answer. And see you in the next video that we are going to focus on this grid world example and training.